Okay, we're back with function notation and vocabulary, talking about determining the domain and the range for this video. And I have 3 examples that I'd like to show you. Let's just start with this first one, f of x equals the square root of x. Let's take a look at it graphically as we go through. So, sorry about that. Why don't I stick a little graph there first? Okay. Now remember, we're calling this the y-axis, but we can also say, if we're talking about a function, that's equal to f of x. And here's our input. For the square root of x, let's just consider some values. If x is 0, square root of that is 0. Okay. If x is 4, then the square root of that is 2. So let's say x is 4, square root of that is, we'll just call 2 somewhere arbitrarily about right there. What's the next perfect square? If x is 9, somewhere over here, then the square root of that is 3. And you get this curve that kind of looks like that. Okay? Sort of tapers off. But it does keep going up no matter what, no matter how slow it keeps going up. So let me ask, what is the set of all inputs that gives us an output? Well, if we restrict our outputs to the real numbers, let's say, then we are not allowed to have negative numbers in for the input. So restricting our outputs to the real number set, then it turns out the domain, I'll just do that as DOM, the domain is really all positive numbers from 0 to infinity. So I can write that in an interval notation, including 0, I use the little guy here, comma, and that goes out to infinity. Okay, so all positive numbers including 0. Infinity is not really a number, it's more of an idea, so we don't include that in our interval. This is the interval of all x values from 0 to infinity, okay? Now how about the range? Well, for the range, it does seem like we're restricted here because the domain is restricted, and it does not appear that we're getting negative values, so we are starting at 0, including 0, so let me do that there. And it turns out that this one also goes all the way out to infinity, so in this case, the domain and the range are exactly the same. The range is the set of all y values, the domain is the set of all x values, both that are allowable for the function in consideration and the number set in consideration. Again, for this example and for these other ones, we're going to only consider the set of real numbers. Okay. All right. Next example with f of x equals the absolute value of x plus 2. Maybe I should write the functions next to these things. This one was y equals f of x, which is equal to the square root of x. Okay. For this one, we'll say y is equal to f of x equal to the absolute value of x plus 2. This plus 2 tells me that my absolute value of x graph is shifted to the left 2 places, so it starts here. And if you start plugging in numbers, you'll see that the absolute value graph, I'll do this one in pink, looks something like a big V, which is nice. That right there is going to go through the point 2. All right. And yeah, that's a V for absolute value, just a nice way to remember it. Now, this one is kind of interesting, again, as far as domain and range is considered. As far as the domain, it looks like we can put in just about anything. And I don't see a reason why we couldn't choose any real number value of x and get a real number value of y equal to f of x, so f of x. Therefore, the domain here is going to be all real numbers. So I'm going to say negative infinity to infinity, again using this interval notation. Or we could say the domain is all real numbers. Ew, that infinity is kind of ugly. OCD is kicking in, but I'm going to leave it alone. Okay, how about the range? Aha, power over the OCD. That's amazing. Well, the range does appear to be restricted. We are not allowed to have any negative values. That is, something you probably remember about the absolute value is no matter what I have in here, positive or negative, the output is positive. And we can see that on the graph. No matter what input I get, the output is positive. So the range is going to start here at 0, inclusive of 0, and go out to infinity in the positive direction, okay, but not inclusive of the negative numbers. So in this case, the domain and the range are slightly different. Now let's look at this other example of the root of 4 minus x squared. Kind of running out of space here. I'll try to cram it in the bottom. And the blue. Okay. Y equals f of x equals the root of 4 minus x squared. There's my x. I got this, or chose this, root of 4 minus x squared from a circle. If you remember, x squared plus y squared equals r squared is the equation for a circle. It's really just Pythagorean's theorem, but it's the equation for a circle. The only thing is when you're doing a function, you can't do a whole circle. If you did the whole circle and the vertical line test, it would not pass, so you can't say it's a function. But I can take a half circle and call it a function. And in this case, the half circle looks like this. Okay. Here's -2, here's +2, and that goes up to 2. So what we're going to say here is that the domain, putting all this in pink, okay, the domain is from -2, and I believe I can include that to 2. That's okay. I get 0 for the y. I don't get something that's undefined, or I don't get an imaginary number. I'm restricting everything to real numbers. So the domain, it's okay to include the 2 and -2. So, whoops. As I'm saying that, I write the wrong symbol. Okay. Here we go. That means I'm including this number. Parentheses means I'm excluding. So -2 all the way to 2 is the domain. That means I get to plug in any x value in that little space there from -2 to 2. The range, in this case, is also restricted. It is restricted to 0, including 0, going up to the radius 2. Okay. So there's the beginnings of the essence for determining domain and range. And let's go elsewhere from here with some additional examples.